A big part of geometry is explaining why mathematical statements are true. And we do this using something called logical reasoning. So in this video, we'll talk about what that means and introduce some related concepts. That includes proofs, conjectures, postulates, and theorems. If any of those words sound a little confusing right now, don't worry about it. We're gonna go through each one and use some Lego examples to help make their meanings clear. So let's start by understanding what logical reasoning is. So it means using facts, definitions, rules, things like that, and organizing them in a clear way to show why something is true. Kind of like organizing the evidence to show that a statement is true. So let's look at this Lego instruction manual here. So the cover shows the final build, but the manual shows the step-by-step instructions needed to get there. So if you follow the steps in order, you get to that finished build. So those step-by-step instructions are like logical reasoning. They organize the steps and follow the rules of Lego building to reach our final build. In geometry, we use a specific type of logical reasoning, and it's called a proof. And a proof is the explanation of why a mathematical statement is true. So you can think of a mathematical statement like the picture of the build that's on the cover, and then the proof is the instructions within the manual that tells you how to complete the build. So there are two types of mathematical statements that you'll come across in geometry. Those are postulates and conjectures. And the difference between them is one needs a proof to show that it's true and the other doesn't. So start by talking about postulates. So postulates are statements that are accepted as true. They're kind of like mathematical rules, and these are taken as facts, and they don't need a logical explanation or proof for you to know that they're true. So they're just taken as fact. So here's an example using Lego bricks. So if we say something like, when the studs on one Lego brick are pressed into the tubes on the underside of another brick, the bricks connect. And then we could call that something like the Lego connection postulate. So as you can kind of see, that's kind of like standard known information, a standard known fact. Each time you build Legos, somebody doesn't need to prove to you that the Legos can connect together. You know that they will. One thing to keep in mind, so the word axiom basically means the same thing as a postulate. So you might hear some people use that term, but in geometry textbooks, the preferred word is postulate. But if you hear axiom, it means basically the same thing as postulate. So yeah, postulates don't need proof. They're accepted as facts. Conjectures, on the other hand, those are statements that need to be proven. So they need to have an explanation, and as we said before, that explanation in math is called a proof. Imagine somebody gives you all the Lego bricks you need to build a set, and then shows you a picture of the final build, but they don't give you any instructions. In a situation like this, it would be your job to develop all the steps to get from the pieces to the finished set. So in geometry, there's going to be a lot of situations like this that will come up. It won't be with Lego, but you'll give in a piece of mathematical information and told it leads to a given result, and then you're going to need to show the steps of how that occurs, how you get from that information to the result, and then that explanation you give is called the proof, or just called a proof. Let's say we have a statement that's something like, if the provided Lego bricks are connected in the correct way, then the gazebo set will be built. This is an example of a conjecture. So a conjecture has two parts to it, the hypothesis and the conclusion. One thing to keep in mind here, the word hypothesis has a different meaning here than it does in science. So in geometry, a hypothesis is like the starting information that you're given. So in our example, the hypothesis is that these are the Lego bricks that need to be connected. And then the conclusion is our result. So an example, the conclusion would be, we would get this finished build. So the way I said that statement, that conjecture is, it has like a part that starts with if and a part that starts with then. So if the provided bricks are connected in the correct way, then the gazebo set will be built. So this is called an if-then format. So in that situation, the if part is our hypothesis usually, and the then part is usually our conclusion. And there's another way that these are formatted as well sometimes, and instead of having that if-then statement, they have like a given label and a prove label. So then for the given label, you would have your hypothesis, and the prove label would be your conclusion. It could be something like, given, when the Lego bricks are connected in the correct way, prove the gazebo set will be built. But you still need, your instruction manual to get from here to here. So this is your proof, the instruction manual. It gives you all the rules and directions step by step that you need to follow to get from your hypothesis to your conclusion. And then when you have a proof that properly shows how to get from here to here, it shows that the conclusion is correct. And when this is done by somebody that's an expert, so when a conjecture is proven to be true by an expert, the conjecture will then be called a theorem. So in math, when it's proved by mathematicians, if we continue with our Lego example, if Lego experts did the proof, then we could call this something like the Lego gazebo theorem. So important note here, don't confuse the term theorem in math with theory in science. So in math, a theorem is a statement that has been proven to be true using our logical reasoning. Whereas in science, so a theory in science is a well-tested explanation for how something works in nature, and it's supported by a large amount of experimental data. And then similarly, earlier I mentioned that the way the word hypothesis is used in math is different from how it's used in science. So in science, a hypothesis is like a starting prediction about how something works in the natural world. But in geometry, a hypothesis is our starting information in our conjecture. In future videos, we'll learn more about specific postulates and theorems, and also learn more about how to properly write proofs. And then in our next video, we'll actually introduce our first postulate, which is the line segment addition postulate.